Hello again. Welcome to the Spirit of Apollo. I'm your host, Mark Lesmeister. So, last time I talked a little bit about the necessity of having a rocket in order to get into space because you have to gain such an enormous amount of speed. So, the question could be asked, how does a rocket do that? To answer that question, let's turn the Wayback Machine to 1920, when an editorial in the New York Times argued that rockets wouldn't work in space. The editorial was in response to a proposal by Robert Goddard. The New York Times opined, and I quote, that Professor Goddard does not know the relation of action to reaction and of the need to have something better than a vacuum against which to react. To say that would be absurd. Of course, he only seems to lack the knowledge laid out daily in high school. Now, this was not the first time, nor certainly not the last time, that a major news organization got something wrong about science. But behind the New York Times mistake is a kernel of truth. Of course, there actually is a principle of action and reaction that plays an important role in understanding how rockets work. I'm referring to Newton's third law. Newton's third law says that forces always come in pairs. So, if you want something to exert a force on your rocket going to the right, the rocket will have to exert a force on that same something going to the left. What the Times editorial gets wrong is the idea that the something that the rocket is going to push on is the air in the atmosphere. In fact, the rocket brings its own something with it. All the exhaust gases that the rocket will push to the left, and the rocket gets pushed to the right. Another way of saying the same thing is to talk about momentum. The rocket gains momentum going one way by expelling exhaust gases with their momentum going the other way. Now, momentum is a quantity that involves both mass and velocity. So if you want your rocket to gain momentum one way, you've got to expel a lot of mass at very high velocities the other direction. That's why most of the rocket is actually propellant, the fuel, that when it reacts becomes the exhaust gases that get pushed the other way. 85% of the mass of a Saturn V rocket loaded on the launch pad is actually the fuel that is going to be expended in giving the rocket its velocity. So here's the rocket before we add on bag 5, which I think is going to basically finish the exterior of the first stage. And I'll show you what it looks like in a moment. Okay, so that completes putting bag 5 on. I believe that these little pieces here that we put on are supposed to represent what looks like corrugated metal on the actual rocket. You need to check that out again sometime. And we are ready for bag 6, which I believe is the famous rocket engines. So until next time, Godspeed.